Welcome to Building Toward Computer Use with Anthropic, built in partnership with Anthropic and taught by Code Steele, who's Anthropic's head of curriculum. Welcome, Code.
Thanks, Andrew. I'm delighted to have the opportunity to share this course with all of you.
Anthropic made a recent breakthrough and released a model that can use a computer. That is, it can look at the screen of a computer, usually running on a virtual machine, take a screenshot, and generate mouse clicks or keystrokes in sequence to execute some tasks, such as search the web using a browser and download an image, and so on. This computer use capability is built by using many features of large language models in combination, including their ability to process an image, such as to understand what's happening in a screenshot, or to use tools to generate mouse clicks and keystrokes. And these are wrapped in an iterative agentic workflow to then carry out complex tasks by taking many actions on that computer. In this course, you learn about the individual features, which will be useful for your applications even outside of LLM-based computer use, as well as see how it can all come together for computer use. And Codes will show you how all this works.
Thanks, Andrew. In this course, you will learn how to use many of the models and features that all combine to enable computer use. So here's how the course will progress. You'll first learn a little bit about Anthropic's background and vision and what's unique about our family of models. Then you'll use the API to make some basic requests. This then leads to multimodal requests, where you'll use the model to analyze images. Then you'll dive into prompting, which Anthropic has really leaned into making models much more predictable with solid prompting. You'll learn about the prompting tips that actually matter, things like chain of thought and end-shot prompting, as well as get a chance to use our prompt improver tools.
Recently, large language models have been supporting large input contexts. Anthropic Claude, for example, supports over 200,000 input tokens, which is more than 500 pages of text. Long inputs can be expensive to process. And in fact, in a long conversation with a chatbot, if you're processing that conversation history over and over to keep on generating that next response, then that too gets more expensive as that history gets longer as the conversation goes on.
Exactly. And that brings us right to prompt caching. Prompt caching retains some of the results of processing prompts between invocation to the model, which can be a large cost and latency saver. You'll also get to use the model to generate calls to external tools and produce structured output, such as JSON. And at the very end, we'll walk through a complete example of computer use that you can run on your own machine. Note that because of the nature of the tool, you will have to run that on a Docker image on your computer rather than directly in the DeepLearning.AI notebook.
I've tried out computer use myself using Anthropic's models and found it really cool. And I think this capability will make possible a lot of new applications where you can build an AI assistant to use a computer to carry out tasks for you. Kind of think RPA, or robotic process automation, which has been good at repetitive tasks, but now easier to build and more general with LLM-based tools. Or as this technology gets even better, then even more flexible, more open-ended tasks that gradually feel more and more like personal assistants.
I could not agree more. Very excited to see where it goes.
Many people have worked to create this course. I'd like to thank from Anthropic, Ben Mann, Maggie Vo, Kevin Garcia, the team working on computer use, and from DeepLearning.AI, Jeff Lodwick and Ephemeral Gagari. Anthropic has built a lot of really great models, and I regularly use them myself. Codes will share the details of these models in the next video.
All right, let's get started.
By the end of this lesson, you'll be able to write multimodal prompts that combine images and text and work with streaming responses from the API. All right, let's go. So let's get started making our first multimodal request. We're going to take an image or multiple images along with some text, send it off to the model, and get a response. So just as in the previous video, we have some basic setup. We're going to import Anthropic, we'll set up our client, and then we'll have just a helper variable to store the model name string. Before we start working with images, we need to talk a little bit more about the messages structure we've seen so far. So in the previous lesson, we set up a messages list where each message had a role set to user, and then content set to a string, like tell me a joke. And if I run this, we should see a joke, and we do in fact get a joke. Not a good one, but a joke. Now this is actually a shortcut. Setting content to a string is a shortcut
for this syntax here, where we set content to a list that contains a bunch of content blocks. In this case, it's just a single content block with a type set to text and then text set to tell me a joke. So this will give us the exact same sort of input prompt, different syntax. Up here, we have a nice shortcut. If we're simply doing text prompts, it's easier to do it this way. But as we'll see in just a moment, we'll want to provide a list of content blocks if we're going to provide images. So if I run this, we again get a joke. And just to show you what I mean about a list of content blocks, here is a single message that has a role of user, content set to a list, and it contains 3 text blocks. Each one has text of a single word. Who made you? And if I run this, we'll see we get a response. I was created by Anthropic. So all of these messages are combined and essentially turned into a single input prompt. So now we go on to images. So our Claude models accept images as inputs, so we need some images to work with. I've provided you with an images folder that contains a handful of images that we'll use. This is the first one. Let's say that we hypothetically run a food delivery startup and we're using Claude to verify customer claims. Customers will send us a screenshot saying, look, only half my order arrived. I want a refund. So we are going to use Claude to analyze images of customer food like this one here. We'll start simple and just ask Claude to tell us, how many boxes and cartons of food are in this image. So the first step is to understand how we structure our messages that contain an image. This diagram illustrates the structure. So if you notice, we have a messages list, we have a role set to user just like before, we have a content list, and then inside of content, we have a new type of content block we have yet to see. We've only seen text blocks, but this is an image block. So type is set to image, it's a dictionary, and then we have a source key set to another dictionary, where we have type set to base 64, we have media type, which is set to the image's media type, like JPEG or PNG or GIF, and then we have the raw image data. So this is the structure of a single message. So back in our notebook, there's a few steps we need to go through before we can actually create that message. We need to read in the actual image file itself. We need to open it, which is what we're doing here with the path to food.png. Then we'll read in the contents of the image as a bytes object. Then we'll encode the binary data using base 64. And then finally, we'll take the base 64 encoded data and turn it into a string. By the end of this, we have our base 64 string, which is quite long, but if we just look at the first 100 characters, here's a preview of what it looks like. So now what we need to do is take this base 64 string that contains our properly formatted image data and now put it in a properly formatted message and then send that off to the model. So here's some code that takes that base 64 string that contains our food.png image data as base 64 as a string and puts it in a properly formatted content block, an image content block, as you can see. Type is set to image, source is set to a dictionary, type is base 64, it's a PNG, and then data is set to our massive variable base 64 string. And then we follow it up with a second content block, this time a text content block that has the text of how many to-go containers of each type are in this image. Very, very simple prompt. We're sending it this image of to-go containers filled with food. We want to know how many of each type are in there. Okay, so now we just take this messages list and send it off to the API. So we use the same syntax we've seen before, client.messages.create. We pass in messages, we'll run it, and we see a response. In this image, there are 3 rectangular plastic containers with clear lids, and then 3 white paper or cardboard folded takeout boxes, often called Chinese takeout boxes or oyster pails. That is correct. If we go back to the original image, we do in fact see 3 boxes with plastic lids and 3 of the paper oyster pails or Chinese takeout containers. Now going through all these steps to read the image and turn it into base 64 and then turn it into a string, encode it in UTF-8, and then add it to a properly formatted message can be a little bit annoying to do over and over, so it's a great candidate for making a helper function. So here's a helper function that just combines the functionality we saw previously. It's called createImageMessage. It takes an image path, and then it's going to run those steps that we saw previously. So it's going to open it, read in the binary data, it's going to encode it with base 64 encoding, it's going to turn it into a UTF-8 string, it's going to guess the MIME type, Remember, we need to specify whether it's a PNG or a JPEG or a GIF or some other format. And then finally, it creates an image block properly formatted and then returns that image block. So let's try it with a different image. The images directory has a plant.png image. It's a pitcher plant. Technically, I think it's a Nepenthes plant. I have had limited success growing these myself. I usually kill them before the pitchers emerge, but very cool plant. I'm going to ask the model just to identify the plant. Very simple use case. So we're going to use this function we've defined, and here we are. I have a new messages list, a single message in it with role of user. Content is set to a list containing the result of create image message for the plant.png image. So we get that properly formatted message back, or technically it's a content block. And then we follow it up with a text content block, asking a very simple prompt, what species is this? We'll send it off to the model, we'll run it, we'll print out the response. And here we go. This appears to be a Nepenthes pitcher plant, which is a type of carnivorous plant, and on and on and on. Okay, so just a little helper function to make things a bit easier. You could take it a step further and make a helper function just to generate the entire messages list itself, where you provide an image path and you provide a text prompt, like what species is this? Next, let's take a look at a more realistic use case that a lot of our customers are using Claude to help with, which is analyzing documents. So many documents, let's take an invoice like this one, which is called invoice.png, includes tons of important information. Maybe it's a PDF, maybe it's a PNG. We can feed it into Claude, give it a good prompt, and ask it to give us structured data as a response. So I might be able to turn thousands of invoices into JSON and store them in a database in a matter of minutes. So here's what that could look like with a single example. This invoice.png image, I provide an image message properly formatted. Then I provide a text prompt, a pretty simple one, generate a JSON object representing the contents of this invoice. It should include all dates, dollar amounts, and addresses. Only respond with the JSON itself. I'll send it off to the model, and we get a JSON response back. So it has the company name, which is my company, Acme Corporation, our fake address. It has information on the invoice number, the date, the due date, information on who it's billed to and their address, the items in the invoice, so enterprise software license, implementation services, premium support plan, and then it has totals, including the subtotal, the tax rate, the tax amount, and the actual total. And if I scroll back, you can get a closer look at that image and see that all this information is in fact accurate. So just a slightly more realistic use case for image prompting compared to, identifying a plant species. Now, one thing we won't demonstrate here, but it's important you know it is possible, is providing multiple images in a single message. Recall that all of our content blocks are treated essentially as one prompt behind the scenes when they're fed into the model. So I can provide a combination of multiple image blocks plus multiple text prompt blocks as part of a single user message. Content is a list, so I simply add my content blocks inside, whether they have a type set to image or a type set to text. The second topic we'll cover in this lesson is streaming responses. What we've seen so far using client.messages.create works great, but if I give it a prompt like write me a poem, what you'll notice is that we're waiting for a response until the entire response is generated and ready. So it doesn't take all that long. That was maybe half a second, maybe a second or less, and we get the entire generation all at once. But the longer a model's output generation is, let's say we're writing an essay with the model, the longer it will take before we get any sort of content back. We don't get a response back until the entire output has been generated. With streaming, we can do something a bit different. We can get content back as the content is generated. And this is great for user-facing scenarios where we can start to show users responses as they're being generated instead of waiting until a full generation is complete. So streaming doesn't actually speed up the overall process to generate. It just speeds up what we call the time to first token, the time that you see the first sign of life, the first piece of a response. And the syntax is a little bit different, but very similar to this client.messages.create. So here, we now have client.messages.stream. And notice, we pass in max tokens, we pass in a list of messages. My prompt is simple, just write a poem. We pass in a model name. But what's a bit different is that now we're going to iterate over this thing that we're calling stream. So I give it this name as stream, and then I iterate over every single bit of text in stream.textstream, and then I print it out. So what we'll see when I run this, I'll just go ahead and execute it, is we see the content coming back as it's generated, instead of having to wait for the entire thing to be generated at once. Let's try it again. You can see that we get chunks, little chunks one by one, and we're printing them out as they come in. But again, the overall amount of time that it takes to do this generation is going to remain unchanged. Now, it obviously varies from one request to another, but we're not magically getting the full result any faster than we would without streaming. We're simply getting results, we're getting parts of the output as they're being generated. So we've seen how to make image requests, sending images as part of a prompt in the content. We've also seen how to stream responses back from the model. Now what I want to do is once again end by showing you a real example from our computer use quick start implementation. So this is a function that does a bunch of stuff, but if you look closely in here, in this highlighted text, we are appending a correctly formatted image using the format that we talked about earlier in this lesson. So type is image, source is a dictionary, type is base64. Now what are these images? These are the screenshots that we're providing the model with. As we've seen previously when we covered sort of an introduction to the computer use aspect of this course, the model works by getting screenshots, analyzing the screenshots, and then deciding to take actions. So we need to be able to provide images to the model, and we use the exact same syntax we've already seen in this lesson. We create these image content blocks. A lot more complicated use case here than identifying a plant, but it's the exact same syntax. So we're slowly growing our arsenal of tools. Next, we're going to talk about some more real-world or complex prompting.
By the end of this lesson, you'll be able to structure effective prompts that get consistent, high-quality responses from Claude. You'll utilize proven prompting techniques that actually matter in the real world, and you'll understand the difference between prompting a chatbot like Claude.AI and writing enterprise-grade, repeatable prompts. Let's get coding.
So the main focus of this lesson is really on the distinction between the types of prompts that we might write as consumers or as users of a chatbot like Claude.AI, and the types of prompts that large customers are writing, or really any API customers are writing, that need to be repeatable and reliable. This is the Anthropic documentation. We have a section on prompt engineering with a whole bunch of different tips and strategies, a lot of which do matter, but some of which matter more than others, which is what I want to talk about in this video. I want to focus on the tips that are worth your time. There's a lot of stuff out there on the internet around prompting. Some of it is a little bit dubious. So we're going to really focus on the prompting tips that have empirical evidence to back them up. But first, I want to show you an example of what I mean when I say a consumer prompt versus a real-world enterprise prompt. So I'm back in a notebook. I have the same initial setup we've had from previous videos. And here's an example of a potential chatbot or consumer prompt that I might type into the Claude.AI website. Help me brainstorm ideas for a talk on AI and education. And if I'm happy with the result, great. If not, I have as many opportunities as needed to follow up and say, whoops, actually you're focusing too much on AI, not enough on education. Can you change this to a bullet pointed list? Can you make this markdown? Right? I can follow up over and over and over again. I have a lot of wiggle room and room for forgiveness. Now let's take a look at a potential enterprise-grade prompt. Now I'll warn you ahead of time, this is quite long and way too much to read and go over in this video, but that's kind of the point. I want you to see that these prompts get long, they get complicated, they have structure to them. A lot of effort goes into creating these prompts beyond just sort of coming up with a thought and following it up with another thought in the way that I might talk to Claude.AI. So this is an example of a prompt that takes customer service calls, transcripts from a customer service call, and then generates JSON summaries. And we might be doing this thousands of times per hour, or maybe even per minute, if we're running a massive call center, or we have a huge customer support team. So we're not going to go over this piece by piece, but I'm leaving you with this prompt so that you can go over it if you'd like. There are a few things in here we'll refer back to. The first thing that I want to highlight, though, is that for enterprise-grade prompts, for repeatable prompts, we really think about them as prompt templates, where we have some large prompt structure that largely stays the same, with a dynamic portion or multiple dynamic portions that are inserted as variables. So in this example, it starts by saying, analyze the following customer service call and generate a JSON object. Here's a transcript. And then on this line, we have a placeholder where we actually would insert the real call transcript. So we would do this dynamically, just using a string method, most likely to replace this with a real transcript, and then another real transcript, and thousands of them in a repeatable way. So we think of this more as a template instead of a one-off use case, like you might consider your prompts for Claude.AI. So back to the slides for a moment. I've listed some of the more important prompting tips here, and I've bolded the ones that I think are the most important, or more important than anything else. So one of them is use prompt templates. We've hinted at that idea. Other things on here include letting Claude think, also known as chain of thought. We'll talk about that in a bit. Structuring your prompts with XML. We saw a little bit of that in the prompt I just showed, but we'll also focus on that in the next few minutes. And using examples. These are all techniques that have real data behind them that actually back up the claims that they matter. So now what I want to do is go through these and try and build a relatively real-world prompt. It will get a little bit long. Prompts do get long. It's a lot of text, a lot of strings, but we're going to go through this one bit at a time. We're going to go about this by building up to a larger real-world or enterprise-grade prompt, and the idea that we'll be using is a customer review classification and sentiment analysis prompt. Let's say that we run some fictional e-commerce company, Acme company, and we have hundreds of products and thousands of customer reviews. We're going to use the Claude API to help us understand the sentiment of those reviews and some common complaints. So if this is a hypothetical review, I recently purchased the XYZ smartphone. It's been a mixed experience. It lists some positives, some negatives. It says, I expected fewer issues. I want Claude to be able to tell me in a repeatable fashion, is this a positive review, negative? Is it neutral? And I wanted to highlight some of the key issues and points of feedback. Specifically, if we're doing this at scale with thousands of reviews, I probably want the output to contain some easily extractable and easy to work with output format. Often that will be JSON. Maybe something like this. Some repeatable object that always has a sentiment score, positive, negative, or neutral. It has some analysis under a key called sentiment analysis, and then it lists the actual complaints. So performance lag, poor value, unreliable, facial recognition, and so on. And then I can easily do this at scale for thousands of reviews, store them in a database, compare them, build charts, whatever I want to do with this repeatable output. So we're going to approach this piece by piece. With our task now defined, we want to take customer reviews and turn them into JSON with sentiment analysis information and customer complaint data extracted. We're going to go through this one part at a time and then build up the entire prompt. So the first tip we'll talk about is setting the role for the model. Now this is actually one that I don't feel as strongly about, so we'll go through it pretty quickly. Something that can be useful is just giving the model a clear role and set of expectations up front. So in this case, it might look something like this. You are an AI assistant specialized in analyzing customer reviews. Your task is to determine the overall sentiment of a given review and extract any specific complaints mentioned. Please follow these instructions carefully. So obviously this is just one piece of the prompt, but we're setting the role or setting the stage, giving the model some context as to what it's supposed to be good at. So the next step here is to provide the actual instructions to the model. Right? If we scroll up, we told the model, please follow these instructions carefully. Now we're going to give it a very clear and direct ordered list of instructions. So the first instruction is to review the following customer feedback. We're making this a prompt template where we'll actually insert a customer review here. Now you don't have to use these double curly braces. You can use whatever sort of variable that you want or placeholder that you want to replace. We like to use double curly braces, but definitely not a requirement. Additionally, notice that I'm using XML tags here. Not a requirement either, but Claude models tend to work very well with XML tags. You can use any sort of syntax or any sort of separators to tell the model, here's where the customer review begins and here's where it ends. Some of these customer reviews might be short, a couple of sentences, but for some very disgruntled or very enthusiastic customers, we might be looking at thousands of characters. So we want to clearly tell the model, here's where the review begins, here's where it ends. The next thing that we'll focus on are the actual steps we want the model to go through, right? We've provided it the context and said, we want you to review this customer feedback. We will then eventually insert the customer feedback in here. What do we want the model to do? It may be tempting to simply say, generate JSON that includes a sentiment score, is it positive, neutral, or negative, and a list of complaints that you've extracted. And that may work. It likely will work in a lot of situations. But one of the prompting tips I want to highlight here is what we call letting Claude think, or chain of thought. Essentially telling the model that before it comes to a decision or some sort of conclusion, we want it to think out loud and output some analysis to help it make a decision, and then eventually make that judgment. So here's an example of what that could look like. In this variable, instruction part 2, another long string, I'm telling the model, here's your second step. So once you've reviewed the customer feedback, I want you to analyze the review using the following steps. There's a few things I want to highlight. First of all, this line here tells the model to show its work in review breakdown tags. Again, you don't have to use XML, but the model performs very well. The Claude family of models perform well with XML. So a common strategy is to tell Claude to contain certain parts of its output in certain XML tags. So we can tell it to do its thinking out loud inside of review breakdown tags, separate from the actual analysis, the final result. We'll tell it to put its results in some separate tag. We tell the model to start by extracting key phrases that might be related to sentiment. Then we tell the model to consider arguments for positive, negative, and neutral sentiment, do the actual determination of the overall sentiment, explain its reasoning, and extract complaints that it finds within the actual customer review. And then we tell the model it's okay for this section to be quite long as you thoroughly break down the review. Now, this is not something that every single prompt needs, right? This can result in unnecessary output tokens because the model is going to generate a whole bunch of thinking before it actually generates the actual results or the actual final analysis in JSON. So this is not something that you need to turn to immediately, but I'm showing it here because it is one of the more powerful techniques to get better results from the model. Which brings us to our next set of instructions, details on the final output that we want. So in addition to the instructions about thinking, we're then going to tell the model in our third part of the instructions. Remember, we're going to combine all of these pieces together into a single prompt. We're going to tell the model in this third part to generate a JSON output with this exact structure. I want a sentiment score, a sentiment analysis. So the score is simply positive, negative, or neutral. The analysis is more details, and then an array of complaints. And I want this to be done inside of JSON XML tags. Again, doesn't have to be XML, but I want some way to extract this easily, right? This is the meat of the response. And if I'm doing this thousands of times over and over and over, I need an easy, repeatable way to get that JSON out. And then finally, I end with some basic reminders. What happens in the edge case if there are no complaints? Use an empty array. Now that we have all these pieces to the prompt, let's put them together. What I'm going to do is make a final prompt variable. I'll make it an F string and I'll dynamically insert the various parts of our prompt. So we have the setting the role part of the prompt, followed by our instructions part 1, part 2, and part 3. Now, my recommendation is not that you necessarily write these in individual chunks like I have. I've just broken it up to make it easier to talk about and to sort of walk through one piece at a time. Now let's take a look at our final prompt. So I've printed it out, and here it is, all the pieces together. So now what we'll do is write a function that takes a customer review, inserts it into this prompt, and then sends it off to Claude, and then finally extracts the JSON output. So here's a simple function called getReviewSentiment that uses the final prompt that we just assembled from all the small pieces. It expects us to pass in a customer review, and then because we're using a prompt template, remember, we're going to replace our little placeholder of double braces customer review with the actual customer review that's being passed into the function. Then we send a request to Claude. So we build our final prompt, we call it prompt, and then we send that off in this list of messages. And then I'm doing two things. The first thing I'm doing is just so we know it's working, I'm printing out the entire model's output, which is this line right here. I print the entire output. This allows us to see the thought process Remember, we told the model to perform some thinking, some analysis out loud, and then we're going to extract the content in between the JSON tags. So I'm using regular expressions here to help me do that. I'm searching for whatever is inside of JSON opening tags and JSON closing tags. If you remember, when we built this prompt, we told the model, generate a JSON output that follows this structure. Inside of JSON XML tags, put your JSON inside. So we do that, and then we'll print out the final JSON output, which is the thing we're really after. And then if we don't find that for some reason, we'll print there was an error or no sentiment analysis in the response. So let's try this with a very simple review. I'll just write a very simple one right now. All right, so here's a very simple review I just wrote. I am in love with my Acme phone. It's incredible. It's a little expensive, so worth it. I love the colors. Pretty positive. Let's try running this now with our function, get review sentiment with our first review. All right, I'll go ahead and run the cell, and we'll see our response gets printed back. Right, so it extracts the key phrases, it does its thinking out loud, here's some positive stuff, here's some negative stuff, here's the analysis, the overall sentiment, complaints, there's really just one, it's a little expensive. And then finally, at the bottom, we could see the actual JSON that we extracted. So sentiment score is positive, here's the analysis, here's the complaints. Not very many complaints, it's just a little expensive. So here's another review, a lot longer, it's a bit more mixed. It lists a lot more issues. We're not going to read it together, but this is maybe a bit closer to a review someone might write. Now let's try running this through the model. So I'll run this for our review2 variable. And this time we get output again. Quite a lot of output. It extracts the positive phrases, the negative phrases. It does the analysis itself. It's a bit more conflicted, it's mixed, but it says the negative aspects outweigh the positive ones. So this also gives us sort of a trace, right? We can understand why Claude generated a certain output, which is another advantage of having it think out loud. And then it extracts the complaints. And then finally, it gives me my JSON output that I can extract and do something with, store in a database, and repeat this tens of thousands of times. One tip that I elected not to show because it tends to get very bulky and long to write is examples, also known as n-shot prompting. The idea here is that we can show the model in the prompt corresponding inputs and outputs as examples. So here's an example of what that might look like. It's quite long and not necessary in this example or in this particular prompt. But if you're trying to get the model to do something that it's having a hard time with, or it's being inaccurate with, or not following the right format, this is one of the go-to strategies. So what we're doing here is telling the model, here are some example inputs and outputs to help you understand the sort of analysis we're looking for. And then I'll simply say, here are some examples inside of XML tags. Here's the first one. Here's a customer review as the input. Here's the ideal output you should give me. And as you can see, it gets quite long because the ideal output is long in this case. And this is for one example. In the real world, when you are providing examples in your prompts, you often want to cover a whole bunch of different cases. So in this situation, at least a positive review, a negative, a neutral, maybe an edge case where there's no review, it's empty, or the review is in a different language. We want to cover our bases. So writing these production level prompts really can be a lot of work. Now we'll end by taking a look at the Anthropic Console's prompt generator tool. So this is not necessary to complete this course in any way, but this is a tool that helps you get the first 75% of the way to writing a real production grade prompt. So I'm going to click on generate a prompt. So maybe the prompt that I need help generating is a marketing copy generator, where I pass in things like a product description and bullet points, maybe an image, the audience that I'm hoping to reach, and a desired length. Maybe I'm trying to write, a tweet versus a full blog post versus an ad. I want help generating marketing copy. So I'm just going to hit generate. And what we're going to get is a prompt that's generated. It's using some streaming, by the way, which we covered previously. You can see it streaming in. And this prompt, if we take a close look, will include things like prompt variables, where I insert the product description and the target audience and the desired length. And then I can decide I want to work with this prompt. As you can see here, I can play with the prompt. I can click to improve the prompt. I can also scroll up further and actually add in examples
that will be dynamically added to the prompt. So this is a tool that just makes the initial pain points of writing these long prompts much, much easier. It still won't give you a perfect prompt on demand, but it's much better than starting from a blank page.
By the end of this lesson, you'll be able to use prompt caching to reduce costs by up to 90% and reduce latency by up to 85% for long prompts. Let's give it a shot.
Let's start by understanding what prompt caching actually does. What are the benefits and how does it work? Essentially, prompt caching is a feature that helps us optimize API usage by allowing resuming from particular prefixes that our prompts may have in common. In short, we can cache stuff that is going to remain consistent as a prefix from one API call to the next, drastically reducing processing time and costs for any sort of repetitive tasks or prompts that reuse consistent prefix elements. So let's take a look at some diagrams before diving into some code. So on the left, we have a hypothetical prompt. I'm just representing it as shapes. So this is our prompt that we're going to send off. None of it has been cached to begin with. So we send this request off to the API, it's processed, and let's say that we decide to cache everything that we send off to the API. So at this point, we now have all of our prompt prefix, the previous prompt from our first request, stored in a cache. On a follow-up request, I now have a longer prompt. It contains the exact same prefix from the first request, but a whole bunch of other stuff afterwards. We no longer have to process, or the API no longer has to process the entire prompt. We've cached that prefix from the previous turn. So when I send this new request, we're going to get a cache hit. We'll read from the cache, meaning we don't have to reprocess all those tokens. And depending on how many tokens that is, that can save us a lot of time and also save us a lot of money if we're reusing it over and over and over again. And then we can write more to the cache and keep this process going, where we can incrementally, if we want to, add to the cache as a conversation grows, or we can just cache some particularly long part of our prompt. Back in your notebook, there's the same basic setup we've had. We're importing Anthropic, we're setting up the client, and we have our model name string variable. Now, to see the most obvious difference with prompt caching, basically with and without prompt caching, we are going to use a very, very long prompt. You're actually going to use the entire text of the book Frankenstein by Mary Shelley, which is available inside of a file called frankenstein.txt. So the first step here is to open that entire file and read the contents just into a variable. We'll call it book content in this case. Book content is going to be a very long string, as you can see here. Here's a small slice of it, so we can see some of the contents of the book. Okay. The next step is to send this off, the entire book, along with some prompt, like what happens in chapter 3. Any simple prompt will do here, ideally something to do with the book Frankenstein. It's all in a function called make non-cached API call. And you'll see that there's some timing logic in here to start a timer before and after, essentially to calculate the time between the request being sent and the response being received. And then at the end, the function returns the overall response, and then the delta, the time between the start time and the end time. To be clear, this version uses zero caching whatsoever. And the highlighted line is where the entire book content, that massive string, is being provided. Notice it's wrapped inside of book XML tags. Not required, but it's a nice way just to separate out for the model. Here's this massive document, and at the end, here's the question. What happens in chapter 3? It is separate from the actual book. So we're just demarcating the bounds of this massive book. The next step is to call the function. So this line calls the function, this line prints out how long it took, and then this line prints out the actual content we get back from the model. So run the cell and wait. This is a very long prompt, so it may take a while. The response came back. In this particular instance, it took 17.77 seconds. Again, no caching involved whatsoever. Here's the actual response, which, to be honest, is the least important thing that's happening in this function. It's more important to focus on the time element, as well as the actual usage, which is right here. So you can see that there are quite a few input tokens that were processed, 108,000 input tokens, followed by 324 output tokens. That's just the number of tokens used in the generation. And 0 cache creation input tokens and cache read tokens because we haven't involved caching yet at all. Now you can move on to the cached version that actually takes advantage of our explicit caching API. This is a function virtually identical to the previous one, except it's called make cached API call instead of uncached. And there's one very important addition right here. So in this content block, where we're providing the massive book content, there now is a cache control property, or a key, set to a dictionary that has type of ephemeral. Anytime you want to set a caching point, essentially telling the API, I would like to cache all of the input tokens up to this point so that I can reuse them next time, our API will do that. It needs to look for this tag. It has to be here in order to know that we want to write to the cache. Now, when you run this the first time, it's still going to take a long time. We won't be having any cache hits because we have yet to write to the cache. So you can execute it. Again, it will take a while because nothing has been cached yet. But as part of this request, the input tokens processed up to this cache control will be cached. That finished running. Here's a response you might get back. So all the content that the model actually generated. But for our purposes, down here is the most important piece. We see that input tokens this time is only counted as 11, output tokens is 324, and cache creation input tokens is 108,427. A large amount of tokens have now been stored in the cache. The next step is to try and read from them. Now, going back to this function that you ran earlier, make cached API call. This cache control tag really acts in a dual purpose manner. The first time that our API encounters this, it will perform a cache write up to this point. So write all 108,000 tokens in the cache. And then on subsequent requests, when it encounters this cache control point, it is then going to look to see, do we have anything cached up to this point? Essentially acting as a read point. So it's dual purpose in that it acts as a write point and a read point. So you can send the exact same function, just run the same function call, the exact same request to the API. This is now going to act as a read. So you can run this line again, new variable names, response to, duration to. That finished running. You can take a look at the usage property of the response to. Notice cache creation input tokens is 0 because there was no writing to the cache performed. Cache read input tokens is 108,000 tokens. Compare that to the previous turn. Cache creation input tokens is 108,000, cache read 0. Same exact request shape, same messages. This time, there was a cache read, so there was no writing to the cache, but there was a massive read from the cache. And if we look at duration 2, 6.2 seconds compared to, in our totally uncached version, 17 seconds. Exact same prompt. I think there was one small difference. This version asked what happens in chapter 3. This version asks what happens in chapter 5, but basically the exact same length of the prompt, just a different number at the end there. So 17.7 seconds compared to 6.2 seconds. And that's without considering the cost savings here. So let's talk about that. The way that prompt caching is priced is very straightforward. Essentially, you pay a little bit of a premium to write to the cache. So cache write tokens are 25% more expensive than regular base input tokens. But the significant upside is when it comes time to do the cache reading. Reading from the cache, those tokens are 90% cheaper than uncached base input tokens. And then the actual input and output, anything that's not cached and any output that's generated, are still priced at just the standard prices. So this means that it may not make sense to cache every single thing for every single message, but if you have some prompt prefix that is going to remain the same across a whole bunch of requests, it can be extremely efficient and cost-effective to cache that long prefix and reuse it. Pay 25% more one time to make the cache write, and then pay 90% less for all of those input tokens for every subsequent request that gets a cache hit. Now, speaking of cache hits, one thing that's important to note is that caches do not live forever. Each cache has a 5-minute TTL, or time to live. So we only support currently, at least, ephemeral caching. And each time you read from a cache, it resets that 5-minute timer. So it also really depends on that use case and how you are using caching and what type of prompt you're sending. But anytime you have a long prompt, you want to save money on, and you're reusing a lot of that prompt, you can use prompt caching. One common gotcha with prompt caching is multi-turn conversation caching. Imagine you have a very long conversation, maybe a conversation involving the book Frankenstein, where the model is sent that entire book text and there's a whole conversation about it, a long common prefix that should be cached to save on tokens, especially if the conversation has dozens or hundreds of turns and each turn is long. What you can do is cache the conversation as it grows. So by setting a cache control point, remember, it really can act both as a write point, write this to the cache, everything up to this point, and a read point, attempt to read from the cache. When working with multi-turn conversations, what you can do is use 2 cache control points that you continuously move down the conversation so that you are always caching the very last user message, and you have a cache control point on the second to last user message. Now, why do you do that? How does that work? Again, it comes down to this dual purpose nature. Imagine that this is a very long conversation that has hundreds of messages. This cache control point, presumably, will get a read from the previous turn. This used to be the last user message, and then we got a response. So this was the last message. A write was performed to the cache previously, and now it acts as a read. There will be a cache hit, and then this now, at the very end, this cache control, acts as the new write point, telling the API, write everything up to here. And then you continue this pattern. So if the conversation grows, which is what this messages list shows, it's the same pattern. Put a cache control on the second to last user message and a cache control on the last user message. Again, this tells the API, write everything up to this point. This is new. And read everything that you can from this point. Because this message, tell me more about Mars, previously was the last message. And you continue this pattern of moving these cache controls down the conversation, the last user message and the second to last user message, to continuously read from the most recent cache and write up to the end of the conversation so that you can read from it next time around. And you go over and over and over. This can confuse some people. It's on our documentation. It's also in this notebook, of course. Now, I'm not making any requests here. This is just the messages list that you can refer back to as an example. But again, it does trip people up. Finally, to tie things back to computer use, this is a little excerpt from our computer use quick start demo that we've been looking at over and over throughout the last few lessons. I just want to highlight that we do, in fact, use cache control, right? Cache control is set to type ephemeral to cache a long history of messages with the model that includes a lot of screenshots, which can take up a decent number of tokens. So if this model is taking actions and it's a 2 or 3 or 4 minute interaction where it is trying something, doing a screenshot, and there's 10 different screenshots and a whole bunch of different tool calls, which we've yet to discuss, caching can significantly cut down on the time and also the cost for the actual computer usage. So we'll get a chance to look closer at this code later. This is mostly just to show you, look, caching is real in the wild as well, not just in our educational notebook.
By the end of this lesson, you'll be able to understand tool use workflows with Claude. You'll define your own tools and implement your own tool-based workflows from start to finish. Let's get to it.
So let's start with an explanation of what tool use actually is. Tool use, also known as function calling, is basically the ability to extend Claude's inherent capabilities. We can give Claude some set of external tools or functions, give it access to those functions, and then allow the model to call those at any point. Although, to be a little bit more specific, the model itself is simply requesting to call a tool or a function. And then we actually do the invocation, we actually do the function execution, and then send the result back to the model. So we'll see some diagrams and we'll build an example of tool use, a little chatbot for customer support step by step. But before we do that, let's talk about why this matters. The short story is that tool use vastly extends the use cases for Claude models. We can take our normal prompts, whether they're image-based prompts or text prompts, and combine them with calls to external functions. And again, Claude itself, or the model itself, is not directly calling the tools, but it's deciding that it wants to call a tool It's passing arguments through, and then we call the actual tool and then pass the result back to Claude. And this enables us to do all sorts of things that the models can't do on their own, like retrieve dynamic data, query our own databases internally, interact with APIs, execute code, search the web, and of course, control a computer. As you'll see at the end of this video, tool use is what powers and enables computer use. The model can output tool calls to click or move a mouse or type and various other computer actions whenever it wants. And then we can execute those actions and tell the model, all right, we did the click you wanted, or we did the mouse move that you wanted. Here's what the screen now looks like, and give it a new screenshot. We'll build up to that. To start, we need to understand how tool use works. Back in a notebook, we have the same basic setup from previous lessons. This diagram shows the basic flow of tool use. On the left, right here, we have our model. We give it access to a set of tools. In this case, inventory lookup, generate invoice, send email. Maybe these are things you want the model to be able to do. And in this particular diagram, the model decides it wants to call the tool called inventory lookup. So step 1, the model says, I want to call this tool. And we'll see what this looks like in a bit. Then it's up to us, or up to you, to actually execute that tool, that function. So inventory lookup with some arguments, presumably is going to connect to a database or some sort of API to do some lookup in our inventory somewhere. Then once you get some results back, you send them off to the model, and the model can complete whatever process it was trying to do. So again, the model issues a request to call a tool, then you have to execute the tool. Then you tell the model about those results, and then the model can carry on and do whatever it wanted to do next. This more extensive diagram details the process. You give the model a prompt and a set of tools. You'll soon see how you do that, how you actually write the set of tools and provide them to the model. Then the model may decide it wants to use a tool. So it outputs that. It says, I'd like to use X tool with these arguments. Then you actually execute the tool. You get some result, right? A return value or data from an API or data from a search tool or from a database. Then you send a tool result back to the model saying, here is the result of the tool you wanted to call. And then finally, the model can do something with that result. So there's a couple of steps involved here. First, you need to have some set of tools you want to give the model. Second, you have to define them in the proper format and tell the model about those tools. And then third, you have to understand the back and forth flow and the proper format for returning a tool result to the model. To start, I'm going to show you a fake database class that we'll be using in place of a real database, just to keep things simple. Imagine we run a company called, creatively, Acme Corporation or Acme Co. And this Acme Corporation has a few different products. We have customers, we have orders. So as you can see here, customers, it's all just placeholder data just to keep things simple. But someone like John Doe has an email, and they also are going to have a username, John Doe. There's an orders list in this class representing the database. Each order has an ID, it has a customer ID, and it has a product, a quantity, a price, a status, whether it's been shipped or if it's processing. Very, very simple, just taking the place of a real database to keep things simple. This class has various functions or methods associated with it, like getUser, getOrderById, getCustomerOrders, and cancelOrder. You can instantiate fake database here, and imagine that you are a customer support representative, and somebody chats with you and says, my name is John Doe, my email is john@gmail.com, I want to cancel an order. If you look at the orders, they don't have John Doe associated or any username associated with them. They have a customer ID. Each user has a customer ID. And if you look at the methods we have available, we have getUser, which will just find a user based off of an email, a phone, or a username. We have getOrderById, which requires an order ID. We have getCustomerOrders, which requires a customer ID. And then cancelOrder, which requires an order ID. So if John Doe wants to cancel an order, it's not as simple as just cancel order unless John Doe happens to know his exact order ID. So there's multiple steps involved. The first step as a human is to get user, based off of this email, john@gmail.com. Then you can see that John has this user ID. The next step is to take that ID for John Doe, find his orders using get customer orders. And then if you are acting as a customer support representative, you would likely follow up and say, I see you have 3 orders. 2 of them have been shipped. We can only cancel a order that has not been shipped yet. Do you want to cancel the smartphone case order? In which case, you could finally take this order ID right here and cancel this order using db.cancelOrder, and that will cancel that order. Okay, so multiple steps involved is the point here. It's all fake, right? Not a real database. But imagine you do run a company with a real database and you want to use Claude to help automate portions of customer support, maybe the low-hanging fruit, and you need to give Claude access to these functions. It needs to be able to look up a user by an email or a phone or a username. And instead of 10 users or whatever we have here, imagine there's tens of thousands. It needs to be able to find orders. It needs to be able to find orders based on a customer. It needs to be able to cancel orders. Just a small set of tools here. So how do you tell Claude about these tools? The first step is to define the schemas for each of your functions. And the way that you do that is through JSON schema. If you're not familiar with JSON schema, it's a common open format that you can use to define, well, schemas. And in this case, Claude expects, or the API expects, tools to be passed in using this JSON schema format. This is a hypothetical tool definition for the getUser method you saw previously. So it has a name, getUser, a description, and these tool descriptions are important to tell Claude, here's what this tool does. And then an input schema that includes the arguments necessary to call this tool. As a reminder, this is what getUser looks like. So the underlying function has 2 parameters, key and value, both of which are required. Going back to the tool definition for getUser, we write the schema to indicate that there are 2 arguments. One is called key, one is called value. Both are strings. Key is one of the following choices using this enum. It's just a nice syntax to say that it has to be either email, phone, or username. The idea here is that you can look up a user by an email or by a phone number or by a username. And there's also a description attached explaining how it works. And then also a value, which is a string, which needs to be the actual email, like john@gmail.com, or the actual phone number or the actual username. And then finally, down at the bottom here, you can indicate which of these arguments are required to call this tool. In this case, both of them are required. So the next step is to define all of these tools. We have 4 different functions. We'll have 4 tool definitions or tool schemas using JSON schema and put them in a list called something like tools. The name doesn't matter, but we'll group them together. This list called tools contains 4 JSON schema tool definitions: getUser, getOrderById, getCustomerOrders, and cancelOrder, all of which correspond to the previously defined methods we saw in our fake DB class. The next step is to give Claude the tools and send a prompt. So this is just a simple one-off example, not in a function, not in any sort of chatbot loop. You have a messages list with a single message from a user saying, show me my orders. My username is Priya123. Then, most importantly, this highlighted line, in addition to the fields we've seen before, or the parameters we've seen like model, max tokens, and messages, now you're passing through tools. Tools is the list of tools previously defined. The model will know it has access to these tools and can decide if it needs to call any. Presumably, if this prompt is asking to show me my orders, my username is Priya123, the model should call a tool to look up orders based off of this username, execute the cell, and then print response.content. Now we have something we've yet to see. There's a text response. I'll help you look up your orders. Let me first get your user details using your username, and then I can retrieve your orders, followed by something called a tool use block. So we have a text block and a tool use block. In this tool use block, if I let's take the last element in this list so we can hone in on that. The model wants to call this tool, which is called getUser. Specifically, it wants to call it with the argument key set to username and value set to Priya123. There's also this tool use ID, which is important because the second step, once the model says it wants to call a tool, is for you to actually execute the tool, then tell the model what the result is. And when you do that, you give the model the tool result itself, the data from the function, along with this ID, so that the model knows how this tool result corresponds to the initial tool use block. The next step is to translate the model's tool use block output, basically stating, I'd like to call getUser with these values, and actually execute getUser with those values, or execute any of the other tools, getOrderById or cancel order or getCustomerOrders. This is a very simplistic implementation, but that's what this function does. It takes a tool name and a tool input, and this is tool input right here. Then it's as simple as taking the tool name and the tool input that the model outputted for you, and then pass them to process tool call to actually execute that function, which is using the database, the DB that you saw previously. And that's the first half. The second half is to then send the result back to the model. To do that, you need to send a follow-up message with a role of user where content has a type of tool result. Tool result must contain the actual content. In this case, this is the content back from calling a tool, and the tool use ID. This ID needs to match the corresponding tool result that you send back to the model. Simply defining this, of course, won't do anything. You need to send it to the model and have some sort of loop or some function so that you can continue chatting or conversing with the model. That's the next step, is to put it all together so you can see the complete flow. This is a simple, complete implementation of a chatbot that uses the 4 tools you saw previously. There's a lot to cover. You don't need to go over it in extreme detail. It's there for you to look at on your own. But this is the core functionality, this function called Simple Chat. It uses a system prompt, which is a way to provide repeated instructions to set the role, to sort of set the expectations of the model. So in this case, the prompt says you're a customer support chatbot for Acme Co. Your job is to help users look up their account and orders and so on. And then in each conversational turn, begin by thinking about your response. Once you're done, write a user-facing response. This allows us to separate out the model's sort of internal thoughts versus the actual reply that we want to show to a user as a chatbot. It's important to place all user-facing conversational responses inside of reply XML tags to make them easy to parse. A note about that, there's a function called extract reply that does exactly what it sounds like. It extracts the contents between reply XML tags. Further down, we start by asking for user input. There's a messages list that starts with a single user message. Maybe it's just hello. There's a way to break out of the loop if the user types the word quit. And then it's all about tool use. The messages are sent off to the model in this loop. All 4 tools are provided as that list of tools previously defined. The prompt, the system prompt is provided, model name, max tokens, all of that you've seen before. Then the model responds with something. You append the message that the assistant responded with. Remember, there's this list of messages constantly growing when you're trying to build a chatbot. And most importantly for this lesson, if the model stopped because of tool use, if you recall, you saw stop reason a few lessons ago. One reason the model stops is because it just reached a natural stopping point. It just is done. Another reason is that it hits a stop sequence. Another reason is that it hits max tokens. And another reason is that it wants to call a tool, so it stops generating. It's waiting to get a tool result. If that's what the model wants to do, then extract the tool use information, including the name and the input. There's a print here that just lets you know that Claude wants to use a particular tool. Then process the underlying tool using the function you saw previously, process tool call. Finally, append a tool result to the conversation history that includes the tool use ID and the actual value returned from the underlying tool function, and then the loop repeats. If Claude didn't want to use a tool, then simply print out the model's response. And then you can try chatting to the model. Simply run the simple chat function and then enter your first conversational message, maybe something like hello to start. There's a response. Hello, welcome to AcmeCo Customer Support. How can I help you? I can look up your account info, check order status, or cancel orders. Let's say I'll pose as Priya, which is one of the users in the fake database with a username of Priya123. So I'll write that I want to check on my order status. And then the model now says, I'd be happy to help you check on that. Provide either the order ID. I don't have that. So instead I'll say, I have my username, which is Priya123. Hit enter. And the model will likely want to call a tool now. It wants to call getUser. And it actually called two tools. The first time it called getUser to look up information about Priya. That then gave Priya's user ID. The model then called getCustomerOrders using the user ID from Priya. Finally, it found the orders and gave a response saying, you have 2 recent orders, a Bluetooth speaker and wireless headphones. Is there anything specific you want to know about those? So that's a simple demonstration of the workflow. To wrap up, we'll return to our computer use quick start implementation. We'll take a much closer look at this in the next video. But I just want to show you that it does in fact use tools. There's an import at the top to import various tools. A computer tool is the one that's most interesting to most people. It includes clicking, functionality, and mouse movement. All the tools are combined into this tool collection variable. When a request is sent to the model, the tools are passed through. The same thing you just saw, tools equals some list of tools. And then once the model's responded back, if it wants to issue a tool or use a tool, if the content block type is tool use, there's logic in here to execute a tool and then make a tool result and send that back to the model. Slightly nicer code, a few helper functions, things are split across files, but it's the same core tool use functionality that you saw in this lesson.